Андрей Витальевич, а вы сами будете экраны менять или нам менять?
Ну, наверное, я сам буду менять.
Хорошо.
Так, и заодно начну запись. Так, хорошо. Okay, I'm glad to see you in this lecture, and I will try to explain you something about numerical methods, physics and in mathematics, and especially our topic today is numerical methods for nonlinear equations. Actually, today it will be one of the most useful methods and one of the most of the simplest methods to solve the nonlinear equation. And this method will be so using this method, we will solve some practical problem. This practical problem is quite straightforward, and I think it will be really useful to solve some problem like with the method to have the live example. So let's start. Okay, let's start. Okay. Firstly, let's discuss the problem. We have some problem. This problem is really straightforward. This problem is to calculate the maximal possible speed of the moving vehicle. It may be motorcycle, it may be car, it may be even plane, which is moving on the horizontal road with known power of engine. So this problem, I think, is really interesting for especially young boys. They always are discussing the speeds of vehicles due to their characteristics, and they just when I was a boy, I just was looking on some car, and I think what is the maximal speed of this car, and I always try to predict the maximal speed, and I always was looking on the magazines with the cars, and I was looking for the maximal speed of the car, not about the power of engine, not about the aerodynamical characteristic, but about the maximum. Let's try to solve this problem. To solve this problem, we will need to use some physics, and we need to use the first principles of mechanics using the Newton equations, and then analyze them and come to some mathematical expression, and then solve it using the computer science. So let's start. We have some vehicle. This is a car, and to calculate, obtain some kinematical characteristic of this car, we just need to use the Newton's equations, and to use the Newton's equations, we need to show each force acting on this car. And let's start. So firstly, we have. Oops. I've shown you all. I have some marker. I will displace it here. Yeah. So firstly, we have the most popular force. It is the gravity force. This force acts on car, and it acts vertically down. So here is our gravity force, and the expression for this force is well known, and it is just m multiplied by g. Yes, this is the force which don't allow our car to fly. But there is another force which compensates this force and don't allow this car to go under the ground. This force is called the reaction force. Actually, the reaction forces act on each of wheels of this car, but we will show the resultant force. It will be vertically up force, and let's call it F react. So it is the reaction force. Well, our car is moving forward, so we just can tell that there is some force which tracks this car forward. It is a traction force. So about the nature of the traction force, we will tell something further. So we have traction force. And also, we have some forces which don't allow our car to speed up infinitely. So at some speed, these forces increases and increases and increases, and this is actually two forces. First of it is the force of dry friction. Actually, it is the force of rolling friction, but we will use expression for dry friction force just not to make our model really complicated, because rolling friction force is has a really difficult expression to calculate. So we will use just the approximate expression for this force, and this is just the dry friction force. We will call it for F friction. And also we have this force actually is really small. You can just see what is value of this force if you just take, for example, the bicycle wheel and speed up this wheel and see how long will this wheel go. So it is a really small force, but actually we also have the air resistant force. Let's show this force. Here is air resistant force, and this force is quite big. So it is F air resistance. So we have four forces, and we need to analyze the system to find some kinetical values of the vehicle. So what is the condition of the maximality of the speed acting on the vehicle, maximal speed of vehicle? So anybody can tell this? What is the condition to vehicle to have the maximal possible velocity or maximal possible speed? Well, oh, okay. The condition is really simple. So you just to have the maximal possible speed, you just need to have the traction force and air resistance with friction force equal. So if the traction force is more than the sum of friction and air resistant forces, then the vehicle will be speed up. Or if the air resistant force and friction force is bigger than traction force, then the speed will be slowed down. But if there are equal forces, then the speed will be maximal. So our condition is that the traction force and is equal to the sum of friction force and air resistance force. So yeah, here is our statement, and here is our condition. So first condition is quite simple. First condition tells us that the car didn't fall down and didn't fly up. And the second condition tells us that the speed of car is the maximum. Now our is to show the expressions for air resistance and for friction and for traction force, and let's start to do it. So what is the traction force? What is the origin? What is the nature of the traction force? Can anybody tell? Well, guys, I'm not biting you. I will not put any minus ball except Gordeev. So you just can relax and tell any stupid thing you want. I am really far away. Can anybody tell the nature of the traction force? What is the nature? Okay, our guys are really shy. Can Gordeev tell us? Okay, can Maxim tell us?
Me? No, I can't, sorry.
Okay, the 10th year in physical faculty of Richelieu Lyceum, it is it's a thing, yeah. Okay. So the nature of the traction force, it is just the static friction force. If you're going, if you make your steps, then you use the friction force to move. So make the car. So here is the nature of the traction force, and we just can calculate this traction force really simple. We can just remember the expression for the vehicle's power. So we just can say that mechanical power is just the mechanical work divided by the time this work is produced. And then we can tell that the mechanical work is, if our force is constant, we can tell that it is just the force multiplied by the displacement of the body and divided by t. And here we have just a velocity. So it is just a velocity. And then we just can tell that this force is the traction force. And then we can tell that the traction force is just the N over V. So it's just the expression for traction force, and we will use it. Okay. So here is our expression. F traction is N over V. And then we will show you the expression for the rolling friction force. The rolling friction force actually has really complicated expression. So complexity of this expression is a bit annoying, but it is not the point of our lecture. So we will just use like the dynamical friction force expression. So it's just the coefficient mu multiplied by m multiplied by g. So it is the multiplication of the mu mg. we will use this expression, and from the internet, actually, from the Wikipedia, we can just obtain the coefficient mu. This coefficient for the asphalt road is just 0.018. So we can use everything to calculate our data. Well, more interesting force is the A-resistant force. Actually, in the high school, people almost never study this force because the dynamics of this force is really complicated. You should use differential equations to obtain the kinematic of the body with the air resistant force, and it is quite complicated. I will show you maybe somehow how to do this, but not in this lecture. Well, where is the biggest issue in this expression? The biggest issue is this velocity. So we usually have the systems with the force which is independent from velocity of the coordinate. It is the simplest situations, and these situations are always in school physics. But here we have the velocity, and this is the complex part of this expression. And also we have this A-resistant coefficient. This coefficient we will obtain from the literature. This is the area of the cross section of the car. So if you have the car, yeah, we have the car. Yeah, I have really strange car. We can make a cross section of the car and find the area of this cross section. And here is S. This is S. And rho is just the density of the air. It is also a well-known value. And finally, we obtain the equation. This equation is a bit complicated, I think. So we have here two functions. In the left part of this equation, we have the hyperbolic function of v. So f1 of v can be expressed as n over v, and this is a hyperbolic function. And here is the parabolic function, f2 of v. Actually, if you multiply left and right part of this expression by v, you will obtain just a cubical equation. And actually, to be honest, cubical equation can be solved using the exact formulas. For example, using the Cardano formula. And however, this formula is really complicated, and I will show you this at the end of the lecture. So we will think that we don't remember this formula, and we will just try to calculate this expression somehow using our mathematical knowledges. So let's start from the obtaining of all the coefficients. I will show you all of these coefficients. Well, firstly, we need to obtain the A-resistant coefficient. A-resistant coefficient just can be measured using the really complicated technique. You just need really expensive and really high quality equipment to obtain the A-resistant coefficient. There are special labs to calculate this, and here is the example of this calculating, so of these measurements actually. So here is the aerodynamical tube, and this aerodynamical tube just produces the aerodynamical streams, and this stream somehow somehow acts on the vehicle, and then we obtain the C. C is dimensionless value, and actually it's just some number. We will obtain this number from Wikipedia. And actually, in talking about this, we will just calculate the maximal speed of this guy. This is Ferrari F50. I chose this car because this is a sport car. This is a famous sport car. So we have almost the whole information about this car in the internet. So I just choose this to have whole information about this car. So our information is like this. So we have the mass of the car. It is 1,230 kilograms. The cross-section area, we just can calculate it using the height of the car and the width of the car. Streaming coefficient or the air resistance coefficient is 0.372, and power engine. So it is just 382 kilowatts, which is not too bad, actually. So our first method to calculate is called the graphical method. So let's see our equation. We have two functions, as I said. We can just plot these two functions and find the place where these two functions meet each other, and it will show the solution of this function. So let's do it practically. I prepared these two functions. Here they are. You see everything, yes?
Yes.
Yes, everything is fine. Okay. So here is the Excel file. In this Excel file, I just tick every value I need. So here is vehicle power, rolling friction coefficient, automobile's mass, free-falling acceleration, air density, streaming coefficient, and cross-section area. So if this is every value, every constant I need to know. And here is our speed. Actually, we usually measure the speed with the kilometers per hour. So it is, if we are actually not Americans, it is the most useful way to express the speed for us. But for SI unit systems, we need to use the meters per second. So tell me, please, how should I calculate meters per second if I have the kilometers per hour? What should I do? Guys, what should I do to calculate the meters per second if I have kilometers per hour? What?
Please go here. Dim, one second, please. Please go here. He doesn't listen to you. He doesn't listen to you. Please go here and repeat this information, please.
We need to divide the velocity in kilometers per hour on 3.6.
Okay, just perfect. We just need to divide it by 3.6. So it is just our expression, and here is the speed in meters per second. And here is our right part. It is just n over v. And here is our left part. It is our expression. It's quite complicated, but it is just the parabolic expression. And here we have the graph. So here is our left part. It is hyperbola. And here is our right part. It is a parabolic function. And here is the place they meet each other. Here is our solution. Solution is somewhere here. To obtain the speed, we just need to have this point and just to put the projection to the axis. So here we have our speed. Here is the maximal speed. So I just made really a rough graph just to show you how does it work, and we can just tell that the speed is somewhere between 300 and 350 kilometers per hour. Somewhere here it's closer to 300, so it's approximately 320 kilometers per hour. Actually, you can just use the internet to find if this value is somewhere close for Ferrari F50. And here we are. So here is one of the simplest way to get the solution for nonlinear equation. It's just a graphical method. But this method has really strong disadvantages, because it is not really obvious for each function how to do this, how to find the place these two graphs meet. And actually, we also can do it simply for one equation, but in real life we have the situations when you need to solve the millions of equations, and for each equation you just don't have a time to calculate all values for right part and for left part, and then to find the where these two functions cross up. So our next method, they called really numerical methods. And let's start from the simplest method. All of these methods are based on the theorem. This theorem is called the theorem of Balzano-Cauchy. This theorem tells us one simple thing. If we have some function, f of x, and I will show you the graph of this function. This function should be regular. About what is the regularity of the function, you will see something in your 10-year. And this function is regular function, yeah? And the condition for this function is that we have 2 points, x1 and x2. And also we know about this function that f of x1 multiplied by f of x2 is less than 0. If we know this about the function, then we can definitely tell that there is at least one zero somewhere between x1 and x2. So somewhere here is 0. So somewhere here is the root of equation f of x equals to 0. To use somehow this method for calculation of the roots, we just need to rewrite our equation. And let's do it. So we just need to put everything on the right part to the left part, and we have something like that. And also we have the function, we will call this f big, and this f big is of v is equal to 0. And let's start to study our first method. Our first method is called sometimes the coordinate search method, sometimes the linear search method. This method is really straightforward. We just need to take some delta v. Delta v is some small value, and we just scan our graph of function f at v and find the region where is our solution. And let's see the animation of this. So we take the delta v. The delta v is just this. This is delta v. Yeah. And let's scan our function. So there is no root here because f at v multiplied by f at, of v plus delta v is more than 0, f at v is bigger than 0, and f of v plus delta v is bigger than 0. And then it also, there is no root, and also no root, and also no root, and also no root. And here is our root, because f of v multiplied by f of v plus delta v is less than 0. So somewhere here is our root. And we can, with some error, with some accuracy, we can tell that the real root is somewhere here. And then if we will scan, then we will not obtain the root. Here is the block scheme of this method. We just enter data, we just scan some part of the function, and if it is not the root, we just continue to scan. And if it is the root, we will just obtain some value. I prepared some simple Pascal code of this function. Here it is. So here on Pascal, I just find this this root. Okay, and here we are. So here is our constants as well. Here is our delta v. It is our step. Here is our variables. One variable is called counter, and here is v and v root. So it's real variables. If you know the Pascal, it's really simple to understand. Here is our function equation. Here is the start of the function, and here is the end of the function. So it's like that. And here is the beginning of our method. So firstly, we just tell our method that v is equal to 0. V is equal to some v0. V0 is the start of our search. Here it is. So we start from the 1 meter per second and end at the 400 meters per second. And then we just make something like that. So we just repeat our method until v is bigger than v1. And if equation of v multiplied by equation of v plus delta v is less than or equal than 0, then we obtain the root, and also we increase the v. And also we have the counter, which increases in each step to have the number of iterations, the number of loop. So let's start our program. So I use quite old-fashioned Pascal, so I just need to compile this. So for this, I need to press Alt-C and compile. Yes, everything is fine. And then I need to run. And then I need to show you the result. So we have the result. Maximal velocity is 316 kilometers per hour approximately, and the number of iteration is almost 4,000. So it's a huge number of iterations, and this is the main disadvantage of this method. So we have really huge number of iterations just to show this, just to show how these functions work. So, okay, let's remember this number. So we have 4,000 of iterations for this method. And now I will show you really good method to calculate this these equations. So, okay, I will exit from here. Exit somehow, yeah. So this is our second method. This method called half division method or dichotomy method. This method is based also on the Balzano-Cauchy theorem, but it is slightly different and it is more productive. So what is the method? We just start from obtaining of the region where we are looking for the root. And then we make something like that. So we just assume that our root is somewhere in the middle of this region. So our root is in f of v, and f of v is the middle of this region. And then if we find this root, we are good boys, and this is good. And if we don't find this root, we make something like that. We just find the multiplication of two of these of pairs of these functions. So if f of v multiplied by f of v2 is more than 0, then there is no definitely root somewhere here, and we just get rid of this region. So we just don't. We are not looking for the root in this region. However, we definitely know that if f of v1 equal to 0, more than 0, and f of v less than 0, then the root is somewhere here. And we choose this region and make the second loop. So let's do it. The second loop makes this like this. So we just have also two regions. We just assume that our root is somewhere in the middle of this region, and also check what happens. So multiplied by f of v1 multiplied by f of v is more than 0. So here is definitely no root, and the root is somewhere here. So we get rid of this region now. Okay. And the next step, the same. So we get rid of this region now, and in this region we have the root. You can easily see that we just made the 3 steps, and we obtain the root with the same accuracy as in the previous method. And now let's see how it works on the Pascal. Okay, I will show you. Here is our Pascal, and let's see how it works. So, before this, let's see the algorithm. So we enter v1 and v2. Then we assume that v is somewhere between. Then we calculate f of v multiplied by f of v1. If it is less than 0, then v is equal to v2. If it is more than 0, then v is equal to v1. And we do it before our accuracy is obtained. So let's check how this method works. Remember that the last method was working for 4,000 cycles to obtain the result. And what about this method? I will not show you how does it work. Well, I will show you. So we have the same parameters. So we have the same function. Also, we just have the left v and right v, and then our assumption v. Yeah, and then our counter. So it is counter for the number of cycles. And also we have the repeat until cycle. Repeat starts, and it stops only if the absolute value of the equation is smaller than our delta f. Okay. So if, as I said, if f of v left multiplied by f of v is less or equal than 0, then v right is equal to v, else v left is equal to v, and then we also make the assumption. So let's see how it works. For this, also compile this program. Alt-C compile. Yeah, and run this program. Alt-R run. and see what's happened. So here is our maximal velocity. It is calculated with the same accuracy as the previous method. But instead of 4,000 steps, we have only 17 steps. So the productivity of this method is much higher than for the previous one. And however, this method has a really strong disadvantage. If on the chosen region we have 2 or more routes, this method will not work correct. So before this method, you just should know exactly that you have only one route on the region. Okay, so everyone is tired, and we are coming to the end of the lecture. And at the end of the lecture, I will tell you about how this problem is solved by mathematicals. So mathematicians just use the Cardano formulas. Well, now no one uses the Cardano formulas from the books. Now people just use the Wolfram Mathematica package, and it gives you the exact solution. And you can see that the exact solution is quite close to our numerical solution. And also you can see that its exact solution is huge. But the last way to solve this problem is how this problem is solved by physicists. So we just can say that the rolling friction force is much smaller than the air resistant force, and it is neglectable. What does it mean? Neglectable? Can anybody tell? What does the neglectable word means?
Сегодня это слово было.
Лилит Саркисовна, вы, пожалуйста, дублируйте ответы, потому что я плохо слышу, честно говоря.
Andrei Vitalich, this word we have used during my lesson on physics. They must know this word.
Okay, fine. So we have neglectable value, and we just neglect this value. So we will obtain only the cubical equation, the simplest cubical equation. So we will have, if we multiply the right and the left part by v, we will obtain the equation like v cubed is equal to, help me, 2n divided by rho CS. And this equation can be easily solved. And the solution is just this cubical root of this expression. So we will obtain the value like 89.46 meters per second, or 322 kilometers per hour. And it's not really far away from the value we obtain. It is higher because we neglect one of the forces, but it is not too far away. It is really fine to use this value just to somehow calculate the maximal speed of the vehicle. So now you can, I hope now you can somehow act when you obtain some strange nonlinear equations in your problems. And I think it may be really useful for you, because these simple algorithms and these simple solutions are really and extremely useful for the mathematics, for the physics, and for the computer science. And if you know this, you may be really good in on these sciences. So Thank you for your attention. Okay, now you can ask me some questions if you don't understand something. Or maybe something about Ireland. We have the good beer. Yeah. And today we have the sunny weather, which is really unusual in our.
Okay, do you have a question? Do you have a question? No?
Ну ладно, давайте теперь на русском. Хоть кто-то хоть что-то понял. Ладно, я не буду уточнять, кто что понял, чтобы не расстроиться окончательно. Окей. Ну, хорошо, как бы... На самом деле, те вещи, которые я вам только что рассказал, на самом деле они очень мощные. И дело в том, что вот эти вот методы, такие как методы половинного деления, как я вам показал только что, и метод по координатного поиска, он используется практически в каждом приложении, которое вы используете вот на своих мобильных устройствах, на, в общем-то, всяких в компьютерных программах, сайтах, практически везде они используются, и, ну, собственно, очень неплохо знать, как это работает, потому что на самом деле, как показывает практика, ну, не все, даже, скажем так, аспиранты даже за границей знают, как это работает, это очень грустно. Вот. Ну и на самом деле это не очень грустно, потому что вы, как минимум, если вы будете знать такие методы, вы будете очень конкурентными по сравнению с вашими коллегами, скажем так. Вот, ну хорошо, наверное, нужно закругляться потихоньку.
Спасибо большое, Андрей Витальевич. Вы нас слышите, да?
Да, я слышу, конечно. Да,
спасибо большое. Мы сейчас в прямом эфире или прямой эфир уже завершился?
Идет прямой эфир до сих пор.
Спасибо большое, ребята. Кого-то есть еще, может быть, какие-то вопросы? Все? Но это уже не в прямом эфире вопрос, Тим. Про пиво вопрос. И есть еще какие-то вопросы? Ну, Тим, задай что-то, нет? Нет? Ну, иди задай, я тебе... Что? Он боится задать мне какой-то вопрос про пиво, но он тебе лично это задаст.
Хорошо, я открыт для дискуссии, у меня есть Инстаграм.
Видишь, вот этот черный футболка, вот парень.
Ну, я вижу некое расплывчатое пятно с черной футболкой. То есть, если что, нужно вопросы задавать, потому что я все равно не узнаю, кто их задал. Собственно, как бы практически анонимно.
Андрей Витальевич, последний вопрос. Сейчас, секундочку. Сколько минус-баллов сегодня Гордеев получил?
Гордеев? Нет, ну Гордееву можно плюс балл добавить. Он там, это вот, что-то там даже на английском сказал.
Он уже фразами говорит на английском, кстати.
Плюс 1 и минус, и все равно 0 получается. Вообще полезно получилось.
Это ты плохо знаешь Валерия Яковлевича.
Мне как-то не сильно спасает ни минус балл, ни плюс балл.
Ну, ты можешь на самом деле заработать минус 12, вот, а потом сказать Валерию Яковлевичу, что он ошибся в журнале.
Я и так и могу это сказать.
Будет у тебя лучше.
И плюс.
Так, ну хорошо, в принципе, давайте, ладно, давайте нашу, скажем так, серьезную часть закончим, я завершу.